Este es el problema primero.
2x
Este es
plus
el
x
problema. The second angle of the triangle is twice larger than the first. You know what the first is though? Ponlo más a F.
Maybe you should write it the other way.
Right. Okay, that represents first. And then we'll put it equal. Porque como no sabes lo que es, es como es. Así no voy a poner what the second angle is. It says the second angle of the triangle is twice larger than the first. If you know what the first is, pues estamos multiplicando con el 2x. Because whatever first is, multiply by 2. Twice as much.
So now like here, x is
So for the third one,
So just look at this one. So x plus x.
third one, the third angle is 20 less than the first. So what's
That's
the
x minus 40 plus
so the first angle, right? Okay, so it's 40 less than x minus 40. So your third angle,
First angle, right?
well, I think x minus 40, but it's
And then there's a third.
same thing, you just divide one. So now you got all three. So la junta las solas.
One of the other two.
X más 2x más x menos
The
40.
second angle is twice the first. The third angle is 40 less than the first.
Yeah, that
The
éramos
first
los
one, yes, now you can write. The second angle is twice.
y luego más x menos 40. You're just adding todo eso junto.
The third angle is 40 less than.
Yeah, so todos están juntando en un lado. And then you get triangle, estamos adding 180 degrees, so you get what equals 180. Equals 180, triangle has 180.
Oh, so the right. Oh, I see.
And then now you can go back and
So it was
go back
60
and find out
years old, and you're 40 less than that.
so
How old
x.
would you be? You're not negative 20, right? So 40 less than something is that thing minus 40. So you wrote 40 minus x. It should be the other way around.
Last one.
Yeah, you checked it. Got it. And you even got the units on there. Kick ass. All right, let's take a look at this. And by the way, this is the time to make mistakes. Right now is the time to make mistakes because then you'll learn what went wrong, why it's a mistake, and don't do it again. Right? So don't feel like you're supposed to be perfect right now. You're not.
You get 140.
I give all of them away.
It's minus 40, so it's plus 40. Right.
So the first one, real quick. Nobody asked me about the first one, so I guess it went well. Right? This is like pseudo math here already. So when 9 is added to 4 times the number, so how do I write that?
4x plus 9.
Good. 9 is added. 4 times the number. The result is 37. So it's like reading an equation in English. So it's that's an easy word problem. And now you solve it.
Yes, by just plugging x back inside. You see how you have the first thing? Plugging x, calculation,
Oh, yeah. Same thing. So addition doesn't matter what order you do it in. Subtraction totally matters.
Okay, so then if this
Stay with me now.
is the second
You make me stop. So this one we talked about already, but just so I can get it on videotape, the width, the length was x, the width was 9 less than that, and then you add them all up. You get 66, you get 4x minus 18. 4x is 84, so x is 21. So x is 21 meters, and then this would be 12 meters. And then check yourself, add them all up, you get 33, and 33 is 66. So you can check your work on a word problem, make sure that they do what they're supposed to do. Are you guys good with that? I just want to do it real quick to get it on the camera. Okay. Let's do it. Number 3 we had fun with. I don't know what the hell the first number is, so I'll call it x. X is the first number. Sorry? What's the second number got to be? X plus 1. It's got to be. If I said I had 3 consecutive odd numbers, how far apart are odd numbers? Give me 2 odd numbers, consecutive odd numbers. 3? 5. So how far apart are they? 2. So then it would be x plus 2, x plus 4, because consecutive odd numbers are separated by 2. And so are even numbers. They're also separated by 2. This was just consecutive integers, consecutive numbers. So they're separated by 1. X plus 1, 1 more, x plus 2. And what are these 3 supposed to do?
to 150.
Add up to 150. There's one number, the other number, the other number. So I get 3x, subtract 3. I get 49, right?
Yeah.
And then x plus 1 is 50, x plus 2 is 51. Bam! And then you check yourself, you add them, you make sure that they do come out to be 150 when they do. There are more than that. You can do this without algebra. I understand that. And the reason I'm making you use algebra is not to be mean, but it's because you're in freaking algebra class. That's the only reason. So we're going to do problems that are easy sometimes. That you're like, I know the answer is 7. But don't get frustrated and go, oh good, I know the answer is 7. So when I do the algebra, I know when I'm wrong. Do you always know when you're wrong? No, you get 2 and you're like, maybe, I'll find, So it's nice to know the answer ahead of time. That's nice. So don't get angry at me if I take points off. If you don't use algebra, you're going to lose like all the points. Because that's the main reason you're here, is to learn algebra. Okay. So then that last dude, right? Not a bad idea to draw a triangle. And then the first step in a word problem. I think as students, you feel like you're supposed to be able to get to the equation, or you want to get to the equation so the problem's over. I understand that. But that's crazy. You can't. It's really difficult to do that. So the first step is always not mathematical. It's artistic, which I know that's a stretch for whatever I draw. You draw something, if it makes sense, and then it's English. So I see the same, I see a second angle, and then I see a first angle, and then I see a third angle. Use the exact same terminology that's used in the problem, so you can always see where something came from. Now, which one do I have to know first? Which one's going to be x? Why is the first one going to be x? Well, they don't tell me what any of them are. But the second one and the third one both depend on the first one, don't they? You guys start to see how to... That's a very important step, is which one's just x. The first one's got to be x. Because now, if I call the first one x, and the second one is twice as large as the first, so the second one's got to be twice x. So I can't do that until I call the first one x. And now this one is 40 less than this.
X minus 4.
So the big mistake people made there was they did 40 minus x. 40 less than something. So the way to do it is start with this and then make it 40 less than that. There you go. You take 40 away from something and make it 40 less. And what are those three supposed to do? This is something you got to know. They got to add to 180. The next mistake people make is they equal it to 0, because that's the first thing you think of when you don't know, is just make it 0. Right? But how could angles add to be 0? That'd be freaky. So I get this angle plus that angle plus that angle. Yeah, there, 400 equals 180 total. And real quick, do you guys know why? What's that mean? What are the degrees there? 90, 90, 90, 90. So it's got a total of... And what's a triangle? Half of that. So it's got 180. Half over 360 is 180. So every triangle has got 180 degrees. All right. And then when you solve this, 2, 3, 4x, add 40, and then divide by 4, you get 55 degrees. So x, and then you can come back up here. Put your answers up here. X is 55, so the first angle is 55 degrees. So what's the second angle? Twice 50. 55, getting there. 110. I like it. And then the third angle's got to be 55 minus 40 is 15. And then to check yourself, do they do what they're supposed to do? They make 180. And you go, oh, thank God. All right, I like it. Cool. So any questions from that? And don't say that. You be careful. People will jump you later.
Yeah, I was going to say, totally.
You gotta be careful. Different things are easy for different people. So, all right. So I just want to do a little bit out of the next section, then we'll head out. 2.4, yeah. I'm just going to do some quick examples. Next time we'll use the workbook. All right. So we won't use the workbook today, we'll use it tomorrow. I just want to talk about the idea of 2-4. Oh, I took a picture. All right. Still going? So let me put down here something we should be able to handle. And over here, I'm going to put something that looks
Scary?
yeah.
Oh,
Alright, now watch. Does anybody realize that I just wrote the exact same equation down twice? If B was 2, and L was 4, and W was 7, would they be the same? So, from a process standpoint, from a standpoint of what the hell do I do to solve this, I do the exact same thing. So this would say, all this crap, but how many variables are there? There's a lot. So it'd have to tell me solve for M. Because they could tell me solve for L or solve for B or whatever. They got to tell me what to solve for when there's a whole bunch of letters. So in this in section 2.4, they'll tell you which one to solve for. How are we doing so far? The reason I want to do both of these at once is so that you see that you do the same things for the same reasons. What would be the first thing I would do here? Add 4. So what's the equivalent thing to do first over here? Why did you add 4 first? Because that's where my M is, right? So I want to get that by itself. So where's my M? There. So I want to get that by itself. I'm going to add L. Over here I get 2M equals 7 plus 4 is 11. Over here I get BM equals W. Be careful. If you write that, why is that wrong? Don't write that. You made it into multiplication, right? You're the math Jesus. I don't know. You write exactly how it sounds. W plus L, I don't know, W plus L, that's what it is. Because I don't know what it is. So like one student said, well that's easier because you don't actually have to do anything. Because they're not like, you can't put anything together. You can't do anything. So it's actually easier. I'm like, cool, I like you. Right? But I mean, at the least, realize how that's the exact same problem as this. They're exactly the same problems from a process standpoint. What I do to each is exactly the same. What do I do next here? So what would I do next there? No. What gets M by itself? Dividing by what's with M. So here I get M is 11 over 2, and here I get M is W plus L over B. Now real quick, that would be the end of the problem. You with me? In section 2.4, that would be the end, because you solved for M. You got M by itself. But just real quick, just to tie these together, what would B have to be to make them the same?
2.
B would have to be 2. L would have to be 4. No? Because it's a minus there already, right? That's why I crossed my fingers. L would be 4, right? Because I'm subtracting 4. And what would W be? 7. So if I put, you're done here, but just to go one step, if I put 7 plus 4, right? Divided by 2, what do I get? Which is the same thing, right? So that is representing whatever W, L, and B are, it means that's what you would get. So if W was 7 and so forth, then you would get 11 over 2. But this is more generally useful. Because what happens in real life? In real life, there's a ton of variables, and we don't know any of them. Oh, shit. But we want to know, if I did measure these, what would M be? So I want to be able to solve for it. If I knew what the temperature of the air was, and the density of the water vapor, and the speed of the wind, and all that shit, I might be able to predict where a hurricane's going to go, whatever. Right? We're sending you, like, hurricanes, what the hell are those? Anyway, baby, that's what. Baby. So, a couple more examples, and then we'll head out. Blah, 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 blah. Oh, I see. There's a little bit of something in there. Okay. So what about this here? This looks very familiar, right? Does it look familiar?
Same thing you just did.
You don't know yet. But that's the equation for a
Linear equation.
I like it.
Slope,
It's the equation of a line. Slope intercept. Kick ass. Slope intercept. I love it. So what if I said solve for m again? Now I like that somebody said it's the same problem. How would you solve this for m? Beautiful. The m stuff is here, so I want to get rid of anything else. Right? So subtract b. Subtract b. What is y minus b?
Y minus b.
Careful, it's y minus b. I really want to make this. If you write yb, you're saying you multiply. But what did you do? Subtracted. So you can't write yb. You've got to represent what you did. So that's y minus b, whatever the hell that is.
Over x.
Careful. Yeah, let's get there. What's left over there?
MS.
Now you divide by x. I love it. Because that gets the m by itself. M equals y minus b over x. Done. Now I understand on one level this is kind of like unsatisfying. Because you want to get 7, you want to get a number. But of course you're not going to get a number answer. You don't know any frickin' numbers, right? But it says if you knew y, b, and x, you do this to figure out m. That's what that says. Alright, so one more example, a little bit more difficult. Let me make it really gross. Sorry. It's all for G. So let's see, what would I do here?
Multiplying this.
Yeah, because you look at it, and what's beautiful in an equation is you're allowed to do the same thing to both sides. So any part of the equation that looks gross, very often you can kill that part, right? So this is really, really gross because it's a freaking fraction. So, like she said, the first thing I can do is multiply by w. Now, is there a w left to distribute?
No.
It died, so let it die. Let it go away. So I get WA equals what?
C minus 2G.
Okay, I like it. Stop there for a second. So now it looks better. Now what's the next thing I need to do?
Subtract C. Subtract C. Subtract.
You gotta subtract C. Why subtract? Because C is positive, right? What's WA minus C? WA minus C, 11. Negative 2G is left over there, right? Beautiful. Then you divide by negative 2. Bam, bam. So G equals, you can run it like this. You could bring the negative up top and change the signs, but you don't have to. Now, even after this whole discussion, I'm still going to have people that just put G equals ACW2. Yeah. You know, I just throw shit in there and hope. Right? That's like winning the lottery. It's not a good chance you're going to just get the right answer just by throwing shit somewhere. But just realize, if you understand how to solve an equation, and you better, then you understand how to solve this. It's a freaking equation. You do the same steps. You've got to actually do the steps, though. Don't just try to get bam to the answer. That's impossible. Sorry, who did? Yes?
Every time, like say example where C is at, since it's positive, every time it's in that position whatever number it is, is it going to be subtraction?
Well, right here I want to end up with nothing here, right? I want to get rid of the C. What is C minus C? 0. Right? If I saw the subtraction and said I better add C, C plus C is 2C. I made my problem worse. My problem is too much shit on that side, right? I want to get stuff away from that side.
So what if it was a 7?
So then you would subtract 7. So yeah, if I had 7 minus 2x equals 4, what's the next step in solving? Minus 7. Right? Do you see that? Because you want to get this by itself, don't you? What's with it? Positive 7. So how do you cancel positive 7? Subtract 7.
And vice versa. If it was a negative 7, you would add.
Yeah, and real quick, let me see if this helps. What's another way to write 7 minus 2x? Negative 2x plus 7. That's how you rewrite it, isn't it? So you're adding 7, so what's the opposite? Subtract 7. That's all you're doing. Alright. So tomorrow, quiz, and then the next day, quiz. Quiz week. Yeah, the week of quiz. Alright, so that's plenty for today. I'll let you guys out a little early. 20, 25 minutes. We'll see. Yeah. I only do like 6 problems or so. Real quick, I don't think I've said this. Have I said this yet? If you have a math teacher that wants you to scantron, they are not a math teacher. I don't know what they are. Because the most important thing is the work. So you will never need a scantron with me because I am a math teacher. Thank you.